Welcome back to Cool Club's headquarters here in Scottsdale. We are here again with CEO and founder of Cool Club's, Mark Timms. And today we're also graced with Gavin Robertson, founder of Accra and director of Aftermarket and fitting for True Temper Sports.
It is a pleasure to be here. Thanks for having me here. It's always great to come back to Cool Clubs and to be able to talk about different products and different things we do around here.
Cool. And this is a bit of a special, product. It links into Accra products predominantly. But this is actually an S3 product, which is kind of an arm branch of our technology at Cool Clubs.
Right.
Mark, lead us in. You tell us a little bit.
Well, for years I've been building stuff, and obviously for our fittings and stuff, we need to know what all these shafts are. And the OEMs have, everyone uses different equipment, different ideas on things. So we need a kind of an apples to apples comparison of all the shafts that are out there. So Gavin actually came to me. I built one, an EI curve machine several years ago. And Mizuno, a few other companies have it still, I think. But just kind of wanted to get something that was faster, quicker, and gave us more data than everything else. So Gavin asked me about, doing another EI curve machine, and I said, well, I got a better idea than that. I just need an engineer to do it.
Yeah, it's funny. You stole some of my thunder there, but I've known Mark for almost 20 years, and it's funny. We had talked over the years about different things, and from the day I first met Mark, he's always had a passion and wanted to know more about how different profiles, how different designs, how different materials and stuff affected the way a product, whether it be a head or shaft or grip or a ball, affected the ball flights during a golf swing. And I mean, over the years, you designed your own EI machines and frequency machines, and one thing I always knew, you didn't trust necessarily what OEMs or manufacturers or shaft manufacturers told you the product was. You wanted to know yourself, and I always thought that was really cool. Then you looked at the machines that Mark designed; they were always over-engineered and crazy with tolerances that were way tighter than anybody else in the industry needed to be, and I thought that was cool. And so over the years, Mark and I have talked about this kind of stuff over and over and over, sometimes over some cocktails. And and the idea really was to really make a better widget. And from my perspective, being a golf shaft guy, we always wanted to make things better, understand quality control, understand designs, understand profiles. And so, yeah, exactly what Mark said. So I had come to Mark about potentially buying or one of his EI machines. And, then Mark sort of came up with this thing, well, we can do better than that.
Right.
And I'm thinking, okay, well, if Mark could do better than his EI machine, which was already ridiculously over-engineered, let's talk about it. And certainly we talked about the idea of a all-in-one machine that could measure all different things on different planes, and it would take the human error out of the equation, all pneumatic clamps and things like that. And from what I remember, you have to correct me if I'm wrong here, we had talked about this a few times and you told me your ideas, and it's like, this is so cool. And then from our perspective at Accra, we had brought on a student from Queen's University, which is a big university where we are, very well known for engineering. And one of the profs there had come to me, and I don't remember how long, about 10 years ago.
Yeah, probably when we started it, yeah.
And they wanted, this kid, Simone Grandin, was going to do his fourth year project, and in the end he was a golf fanatic, and the profs, they were trying to find something really cool for him to do it on. And so he did a project for us on how torque affected flight in the ball, and he did a really good job, and I'm not saying the results were necessarily, but I learned a lot from it. And so literally, I think it was the PGA show, and correct me if I'm wrong, but I think it was the PGA show. I met you in a bar, shocker. And and we had a couple of drinks, and I remember saying to you, I think I got a guy for your dream.
That's exactly right. Yeah, I'm not sure exactly where or when it was, but
yeah,
you definitely did. You
I
said,
think it was a couple days before the PGA show.
Yep.
And literally we started talking about it, and literally within a few months, so that was probably in January. By March, April, Simone had a summer job at Cool Clubs.
Yep.
And that's where it all began. And the S3 machine was created. And literally, I remember phone call after phone call after phone call from our place to your place, deciding what we wanted this machine to do,
right,
what you wanted this machine to do, and we threw in our ideas. And literally, it was just make a list of things one machine could do.
Right.
And
well, way back when we had Hot Sticks Technologies, right? When we started this, we had like 5 different machines.
You had a robot. You're still the only guy that's ever had a robot as a club fitter.
Right.
You've had everything.
Yeah, but it used to take like an hour, and to measure one shaft, and we got out of that probably 100 data points because we put in different machines, and it just took forever. So just kind of came up with the idea of automating all this stuff and finding more information.
Well, from a shaft company, we're the same way. I mean, we had a manual torque machine, a manual EI machine, and a manual frequency machine. We used to do some zone frequency. We used to do, and trying to do EI 1 inch at a time on a shaft. I mean, on one plane took forever.
Yeah.
And for us to create specs and specifications for a shaft, it was crazy.
And I think that is probably where Mark's head's at with that, or how he got to this machine, is that you're going through that issue at that time, as well as a bunch of other shaft manufacturers, and they've all got different tolerances. They've all got different machines. They've all got different people using the machines, and you've got to kind of centralize that way of measuring golf shafts. And then this machine really does do that. And I'm just listening to you here, and I've got so many questions popping up in my head, and there's so much to talk about. But we're now 10 years down the line. I'm pretty sure you're right there, because it was when I first got to Australia, like 2012, 2013 we started. We're on the cusp of 223. So, and I think we've got a mountain of data, at least from a club fitting point of view. I'm sure you do from the shaft building point of view. And we're only just about to kind of tip over the edge of being able to understand it really, really well. From a fitting point of view. But I know that you've had some success using it for production of golf shafts.
Yeah, so we use it for two reasons. One, quality control. We can randomly test a bunch of shafts over a short period of time, and obviously the S3 machine finds any inconsistencies, imperfections in a golf shaft. So we can see quality control very quickly with that. So that's great. We have people running our shafts through this machine all day, every day in some cases, and it's great for that. But from my perspective, when it comes to sort of developing new shafts, it gives me a much better understanding of profiles, much better understanding of what different profiles do during a swing. Because one cool thing about the S3 machine is it's kind of a static test, but it's in a dynamic position. Mark can talk more about that.
Yeah, I'll explain that a bit.
And that was something that was really cool. That we started off one direction with it, and then we ended up by kind of pivoting to a different direction with. I remember it was force originally. Then we went to kind of a specific bend.
Yeah, we do both actually.
Yeah. And the cool thing is it really gave me a better understanding of really what the profile of the shaft does, and the small idiosyncrasies within a shaft. So I mean, I would say our the original TZ5 and 6 were kind of the first shafts that we kind of designed. The TZ6 specifically, it was kind of a wacky shaft, and it was a wacky shaft because we started realizing that we could make a very stiff butt section and a very, very soft tip section, but if we lowered the torque down very low, we could still make it feel stable and have guys like Jason Day and Cameron Champ and some big hitters use it. And that was a really funky design we probably never would have gotten to if we didn't understand the profiles that we were seeing.
Let me touch on that. This is kind of a perfect time for me to delve into some of this. I use it as a fitter, so I'll see these profiles that this machine spits out, which might be different to other EI profiles that we see even from other machines. It reads in the opposite direction, which is one thing. But when you say, right, okay, I wanted to build a golf shaft with a really stiff handle, relatively speaking, a very soft tip, and then up the torque. How do you come up? How do you concept that as, right, this is a product that's missing in the market, and this is what it's going to do to perform well? Why were those the parameters that you targeted?
Yeah. So if you saw on the S3 data an extra stiff shaft, an M5 that had a 17, 18, 19 tip section, so average EI in the tip section, you would probably say it's too soft for most players. And I mean, it's unique in the industry. But then you throw in a 2.2, 2.3 torque kind of thing into it, and you throw in a 120, 115 butt section, it actually becomes incredibly playable.
So the stiff butt gives them the control.
Gives them the feel of stiffness, the strength of loading and unloading. It feels stable, even though they're getting some lag and stuff. As we all know, torque, as much as anything else, it can affect spin a little bit, but basically it's a feel thing. It certainly gives you a much stiffer feel. So all of a sudden, these guys on tour, guys with very, very strong, fast swings, and even that load it quite hard, we're finding that they were gaining a little bit of launch because of the responsive tip, but the spin was staying down because of the torque and the strong butt section. So it worked, but it was something I probably never would have thought of going that direction if I hadn't seen that there was a void in the market for that.
Yeah.
So, and then it really, the next step, I mean, FX, which I think we have up on the screen here, but
Yeah, let's just go through FX and kind of
Yeah,
talk through
FX
some of the numbers and
Can I
show
go
you what the
back?
difference is.
sure, yeah, go
Before
for
we
it.
go to S3, I knew you touched on the point. You said, "Hey, we measure static and dynamic," and you said, "Let's touch on that."
Yeah.
So I thought, let's cover that before we get into
Let me
product.
explain that a bit. So, most EI curve machines, I mean, even the previous ones I've built and stuff in the past, use what's called 3-point bending. So basically, you have a shaft and you put two weights, two supports under about 10-inch span, and you push the center and you see how much it deflects. Then you move over an inch and you do it again. You move over an inch and you do it again. I mean, that's great. It does actually give you the actual stiffness of that part of the beam. But the problem is with a shaft, you can't get those too close together, because if you get them too close together, you actually break the thing. You just can't bend enough. The other thing happens too is, it ovals, right? In the butt section where it's thinner, you push down and it actually bends. And how do you measure that? So there's some issues with doing 3-point bending on shafts. So what I was thinking is, well, wait a second. Really what happens when you bend a shaft and you put load on a shaft, the whole shaft bends, and it distributes that pressure over the whole shaft. So how does it actually bend in that profile based on you actually moving it, how much it would normally move in a golf swing? So what we do actually in the S3, it's based on what's cantilever EI. And what that does is it holds one end, obviously, and bends the whole thing, which is what happens in a golf swing. And then we look at how it bends. So if you think you've got a really stiff shaft in the butt, the shaft part will be pretty, the butt start would be pretty stiff, and then it softens down when it gets to the tip. But you see the whole shaft, right? So you see all the way that comes into the head. And the most important part, and you correct me if I'm wrong here, in a shaft for the most part, all parts are important, obviously, but the tip is the most important part. That kind of determines a lot of, how high or low it goes. And if you're taking 10-inch sections, and you're measuring the tip of a shaft, you can't go past that.
You're missing
So
a tip in the butt
You're missing,
section.
yeah, you're missing it, right? So you don't really see what happens. You can bend the middle to 10 inches. You know how much it bends, but you don't know which side of the 10 inches, is actually bending. So it doesn't show you the whole picture. Whereas what we do, like you bend the whole thing, you take a picture of it, and you see how it bends. We're actually just looking at, the whole profile and how it would actually bend. That's why the name of the machine it's called S3, because it's actually a shaft simulation system. Yeah. So it simulates what happens when you swing it. And then we torque the whole thing and watch that as well, and obviously measure the frequency on multiple planes and measure some other stuff as well. But the real key to it is actually being able to bend the whole shaft like a golfer would do and see what happens to it.
I think that's super important. And I mean, this is a complete sales picture on my behalf here now, but I'm an independent fitter. We are an independent fitting company. We use all the brands. We're lucky enough to be good friends with a lot of people in the brands, such as Gavin from Accra. But we run every shaft, not just shafts that we have in our matrix that we fit with. We run them all. We're checking them all. Manufacturers send them to us to QA them, essentially, and see what's going on and run them against other profiles. So it's a really cool thing for our fitters to have, and we're going to actually start putting this on the website within some reason. For free, so people can access some of the data that we collect and start understanding the shafts that we carry and use in our day-to-day.
Yeah, because it's hard, because you look at Fujikawa's website versus Mitsubishi, both great companies, both do a great job with all that stuff, but they measure in different machines. So, they're not apples to apples. 3.5 torque on one company isn't 3.5 and this is on another. It's how long the clamping, how wide the clamping is, how long the beam is. There's lots of variables, and they're not wrong. They're just all different.
So keep an eye on our website for that next year. You want apples to apples, and you've got all the information here. Get to coolclubs.com.
And honestly, one of the most difficult things we do, and all club fitters do, and even OEMs struggle with this too. Most all companies that are kind of working on fitting software or whatever, or what clubs to put in your demo matrix. So you've got thousands of shafts, and you want, have a demo matrix, whether it's an OEM's fitting cart with 30 shafts in it, or it's ours with hundreds, or some competitors have hundreds. You want all different shafts in there. You want a shaft that fits everybody.
Yeah.
So you want something, if somebody swings 60 miles an hour that gets high, you want something, at 100 miles an hour that kicks the ball higher, and one that kicks it lower. And you also want 3 price points, that's kind of what we look at.
And that is the best segue.
It's really difficult.
You've just created the best segue ever to now into how did you create the FX series? This is it. Right. It's perfect.
Well, first of all, understanding profiles is huge for cool clubs and all the fitters. Being able to narrow down a specific profile for a customer and then being able to find 3 or 4 different shafts from different companies in that profile is something that makes you the leader in a lot of ways when it comes to technology. FX is really interesting. Again, looking at the data we get from the S3 machine, and trying to get deeper into it. One thing we looked at was EI. It's an obvious one. One cool thing the S3 machine does is it takes an average of the butt section, an average of the midsection, an average of the tip section, but you can also segment out different points along the way. So we do both. But the one thing I looked at is when you look at EI, if you have a very strong shaft, we call an M5, an extra stiff shaft, and you have a ladies flex shaft, the EI in each section is going to be much lower in a ladies flex shaft. So I mean, if I look at just a standard, let's use a shaft where it's 100 in the butt section, 50 in the midsection, and 25 in the tip section, and that's your M5 shaft, which would be pretty stiff in each section, or pretty strong in each section. Well, the ladies shaft of the same design generally would be significantly lower in the butt section, midsection, and tip section when it comes to the EI number. So then we started looking at, well, how do you compare a ladies shaft to an extra stiff shaft and say they're the same? So we started looking at the percentage of the EI. So in that shaft that's 150 and 25, well, that's 175 total EI.
Yep. Okay.
And then you look at the percentage of that 100 of the 175, the percentage of the 50 of the 175, and the percentage of the 25.
So your total would be different for the different shafts. And
But
X
the
would be a
ladies-
higher total, the regular would be a different total, the ladies would be a different one. But the percentages of how the stiff the butt, middle, and tip are similar.
So we said, why wouldn't we design? Because the FX line has always, it started off as die match, and die match has a really cool story to it with fairway woods and hybrids that match the driver, and that's a whole other segment. But the idea with the latest FX line was, with all FX lines, was to have a 100 series, which is basically a high launch for the average golfer, a 200 series, which is of a mid launch, and a 300 series, which is a lower launch. In the past, we kind of looked at the tip section as being the most important part, and we always looked at tip section. But then we started looking at, why wouldn't we ensure that all the 100 series shafts have the exact same profile? So we looked at those percentages, and we said, whether it's an M5 or an M1 in the 100 series, let's make sure the percentage of the butt section stiffness or strength is the same, whether it's a lady shaft or a extra stiff flex.
So you'd have 100, 50, and 25 in the M5.
And then reduce that by whatever it is.
60, 30, 15.
Exactly, because it might be 100. Your total EI of the ladies might be 100.
Yeah.
Instead of 175. And then we did the same. So the 100 series is basically, again, very strong butt section, very soft tip section, but you can still make that, even though it's got a strong butt section, when you bring it down to ladies and your total EI is below 100, it really isn't strong, but the percentage is still stronger
relative to
relatively,
the other
exactly.
Yeah.
And then the 200 series, we did more of a mid, and the 300 series, we did the opposite, where it's a softer butt section but very stiff tip section. And again, no matter which flex you are, no matter which weight you are, the same percentage of EI is across the board of all the 300s.
So this graph that we've got up here now, I don't know if
Just let me explain the
Jared
graph
can
real
bring
quick.
that
So on the left side is the butt of the club, right? So that's how stiff the butt is, and on the bottom, on the right side is the tip. So you can see those percentages he's talking about, or how stiff it is, and that's how far out, right, on the bottom.
up. So like you said here,
And this is backwards compared to a lot of EI curves. And the reason it's this way, to be honest, is because I put a clamp on the left.
Yeah.
So if you're looking at the machine, it makes sense, so.
And I read left to right, so it works quite well for me.
I mean, you start with the butt end and keep going. Okay,
Yeah.
let's not go there.
But you've got the softer handle here in the 300 series, just like you said.
Yeah.
And the stiffest tip.
Yeah.
And then
It's a little. It's just the very, very, very butt section's a little mixed up there, but basically, if you look all the way down, the 100 series is generally stiffer in the butt section, and then gets soft. They get softer at the tip, and then the 300 series goes the opposite.
And then, so using this as a fitter, and this is kind of close to some of the profiles I see. Like, I kind of see profiles sometimes that are stiff in the handle and then really get down to soft
Yeah,
in
you
the
see
tip.
a lot of those too. Yep.
I'm thinking probably like TZ6 is more like that,
Exactly.
right? And then a TZ5, which is a little more linear, maybe like softer in the butt, stiffer in the middle,
100%.
stiffer in the tip. So, and I kind of been using that with players, and over the years, 10 years of using it, we've been trying to distinguish, what are these guys feeling? Only looking at the profile, because there's so much other data, it's overwhelming. And you start looking at a torque number, like how much can people feel of torque? It's so hard. But if you I've tried to separate just pure profile and then, you know, use lots of manufacturers around that. So I've seen guys that respond to stiff handles and soft tip and they just like them. So then I just stick within that profile range and we try different shafts around that. And then same with like I think your 360 series is one of the best for those real high speed players, quick tempos, because it feels stout. Although the butt's softer, it feels stout all the way through because the butt's softer. The relationship between the middle and the tip becomes more aligned with each other, so you can't feel the differential of the shaft moving or unloading in the same way as a TZ6 would.
I think understanding the relationship, it's easy to say a softer tip shaft goes higher. And again, it's not for every player, but a majority of players, but it's understanding a relationship between the tip section, the butt section. That's getting back to the old deflection idea of the way we measure EI on an S3 machine. It's a relationship. It's not just the tip section. It's a relationship between the tip and the butt.
Yeah.
And that creates where the shaft actually bends. If you have a very stiff butt section, it's going to bend more in the tip section. So that's why generally it works that way. But it's not always exactly the case when you get the middle ground. And understanding that the butt section does affect where a shaft bends in the tip.
Yes.
How close the tip it bends.
Yeah. Going back up to, we can look at some torque numbers.
Let's just go through the numbers real quick, just from the top to bottom, just what numbers we got. So we actually do list, all the manufacturer specs and stuff on the top of what they're telling us what, and then going through obviously the masses. We actually just stick it on a scale and measure it.
So this is pre-cut mass.
That's pre-cut, pre-paint. Some companies, 65 gram shaft is 65. Some companies, a 65 gram really means it's 75, and they say, well, we finish trimming it, and before we put the paint on, but they're not all apples to apples again. This is actually what they weigh at 46 inches.
Well, this is a good example actually of you call them the 160 and it's 66 grams almost.
Yep.
And lots of people, even your 50 series actually are nearer 60 grams.
Well, the TZ line is now pretty much dead on. We actually we actually did again from S3 machine a lot when we looked at redesigning the new TZ 5 and 6. We actually reverse engineered it. Normally when shaft companies design, they design with an R or S flex and then work from there. And generally the S flex or X flex is going to be a little heavier and it gets a little softer as it gets down to an R flex, especially these shafts here where we go down to a 40 gram double L flex in the 100 series. So because it gets lighter, you don't want to get too light. So we tend to start it at again, like an M4 or stiff flex. With the TZ5 and 6, the new one we actually did is we made the X flex 60 grams for the 60 gram one and went downward. So when you get a 50 gram M3 or R flex, it's actually a sub 60 gram, even though it says 60 on it.
Right.
So we actually have learned from a lot of this stuff to try and get it the other way around. But I mean, this is a perfect example where we're talking stiff flex shafts here. So they are a little heavier than the stated weight or whatever.
Because the regular is close.
But if you got the regular flex, it would be more like 60 grams.
Right. I didn't know that.
Yeah. And then obviously we got the butt
outside diameter.
Outside diameters, which is useful for our calculations for grip sizing later, and the tip diameter, obviously, that's pretty standard to industry. The parallel length's useful because how much can you trim this thing and tip it, which will be another video. Will tell you what happens when you do that. And then obviously we got the butt EI, which is the average of that whole butt section, the mid and the tip, and that's what Gavin's talking about and how you look at different ones. And those you obviously see a pretty substantial difference on the tip EIs. On 3 similar weight shafts, 21 on the far left one there versus 27. That's substantially different.
Yeah, 100, 200, 300.
I was fine with these numbers. In the tip section, 2, 3, 4 points means something.
Right.
In the butt section,
Not
if you have
much.
10, 15, 20 points, it's not as big of a deal.
Yeah, absolutely.
It's a percentage, right?
Well, it's percentage-wise.
It's a percentage, yeah.
Exactly. And an S3 launch is calculated, based on its shaft bending about 3 inches at impact. How much higher or lower does it launch than the average shafts we tested in that area?
And that's key to look at because
It really
obviously
is.
Gavin said, look, this is a high launch shaft that's coming out
Kind of mid.
low, but it's only
Comparatively.
relative to everything else we've got in the system.
Right. And then obviously the mid ones, quite a bit lower, and the low ones, that's substantially low. The most we see is 2 degrees is like the max of the crazy shafts. We don't see ever any more than about 2 degrees, total.
Yeah.
Right?
So just to give people an idea of like using this as a fitter, we roughly know the whole averages of all the golf shafts. If you're seeing a shaft at -1, -2 degrees
that's
launch,
low. That's low launch.
it's going to knock the ball
bear.
down. Yeah.
And if you look at the S3 launch numbers, those are not just us saying like a lot of the shaft companies do, for marketing reasons. This is a low, this is a mid. I mean, you always see all the shafts are high launch, low spin because everybody wants that, but they're not. There's almost no such thing as that animal. You know, these low, mid, and low are just calculated off the data we have, right? They're not just like,
No
we didn't make them
opinion.
up.
Yeah.
They're just numbers that calculate those things.
Yeah.
Frequencies, obviously, you know, we use is basically the old, FM frequency machines, because I used to build them for FM Precisions way back when. But they're not, you know, they're relative to that machine, but you can see they're all very similar.
Well,
I mean, plus or minus a tenth of a flex between all of them.
So what we do, one thing we do with Accra is all of our shafts within a family. It's basically a constant frequency technology, and so when we say M4, which this is here, whether you're using a 40, 50, 60, 70 gram in either a 100, 200, or 300 series, you know the M4 is always going to be 200. Well, 260 is what we, I think, our stated frequency.
Right.
So within one or two, or one basically in each case. So the cool thing from a fitter's perspective with the FX line and all of the Accra lines is you can go, once you decide somebody should be using a 60 gram shaft, you can then go try a 100 to 200, 300 series when you're doing your fitting and know the frequency is going to be the same across the board.
Right.
Yeah.
Or you can jump up and down weights once you decide M4 is right for a guy. Sorry, or you can jump it down flexes too and know that whenever you do get to a certain flex, you can go up and down weights.
Yeah.
So it's kind of cool.
Yep. And balance point is just that's measured. That's really simple number. We just basically balance it on something. We thought about automating that, but it's too easy.
23 inches from the tip section.
Yep. So those are all pretty standard, right? So you would notice those if you got a high balance point shaft, we're trying to keep the swing weight down. Those are all changed, and that's plus or minus a couple inches, really.
Those will all be some mid-low
Yeah.
Yeah.
balance
Those are
points.
mid-low. Yeah,
So they're
those
designed
are
to
pretty
be-
standard. Nothing
Yeah.
weird there. And then obviously we got to build FMs and stuff in there. That's relative to some of our math, not so relative to everybody else. But then we get basically, you know, the launch parameters of those shafts, and you know, these are dead on what you know, marketing says, or it's the other way around. Actually, marketing saying what you guys can't found out.
Well, the good thing, from our perspective, our marketing is based around what the information we find from the S3 machine, so it's pretty easy for us.
Right, right,
And I think I said
exactly,
this
yeah.
shaft was actually designed using the S3 data, so it's perfect, and that's the cool thing about it.
Let's just touch on deflection. We kind of briefly talked about this before we got in, but it's a hard one to get anything out of. At least from a
They
fitness
all
point of
look
view.
pretty similar, you know.
Yeah.
And all shafts look pretty similar on this thing. So I mean, it's the way we measure it, so it deflects it, but obviously the cameras and stuff pick up a bunch of information. So when you tend to that and transfer it to the EI curve, you can see the differences.
Yeah, and the EI curve, that really does
Yeah.
show how crazy different these golf shafts are. So
Yeah.
that's pretty cool. Well, thank you very much for talking us through that. It's a great product. I love it. Like I say, keep an eye on the website, follow us on social media, and check out all of our products. Make sure you go to accra.com.
Yep.
Accra.com.
Accra Golf.
accragolf.com and see all of Gavin's products, and you know how high quality they're going to be. We'll do more with Gavin. We'll talk about some other products from True Temper and Accra coming up.
Thanks so much.
Thanks, guys.